Hello everyone, this is Randy. If you take a look at my channel, you will realize I have several open playlists. Currently, my tutorials are basically in animation node tutorial list and animation node fundamental list. While the tutorial list is to really make something interesting, the fundamental list is to talk about the usage of nodes, bugs, tricks, workarounds, and so on. Basically some stuff that you won't directly learn from menu. Also, likely I will open more playlists, so take a look to that, may be helpful sometimes. Anyway, today's topic is going to discuss the difference between vector and the matrix, which I think is very important. So if you have watched many of my tutorials, a node that I frequently use is to distribute matrices. And interestingly, it has two sockets. One is matrices, and the other is vectors. And at some level, they're the same. Both of them, they can distribute objects over a 3D space. So let me show you with a 3D viewer. So if I connect the matrix into the 3D viewer, you can see it basically distributes markers over a grid that has been generated with these nodes. And if I take a look with vectors, so now it distributes a white markers over the grid that has been generated with these nodes. So now they looks like the same. So now the question comes to be, what's the difference between them so that there has to be two different sockets instead of one? Or can I exclusively use vectors over matrices? And to understand what are they, it might be easier if we know the components of them. So if I combine a vector, you can see a vector is basically three numbers in terms of x, y, and z. So basically you're defining a point over a 3D space, or it can be something beyond the point as well. But it's basically just three numbers. But if you're talking about the matrices, so let's compose the matrices. You can see it has basically 9 numbers. And these 9 numbers basically means locations, rotation, and scales. 3 numbers for each. So in this case, you can basically think a matrix is equivalent to an object, which has a transformed data of location, rotation, and scale, while the vector is just 3 numbers. But of course, you can use vector to compose a matrix, like connect the vector into translation. But the one thing I hope you to be aware is the rotation is not a vector, but a Euler number. So the difference between Euler, so let's combine Euler, is Euler is basically a vector that has a unit of either radius or degree. And you can choose whether I use a radians or degree. So basically, a single pi means 180 degree. So basically, if I were to conclude everything, is that matrix includes more information compared to vector. So how does it actually help in these distributed matrices? So that I need to have two distinctive sockets. So firstly, although the difference is not very obvious over this grid, but if you're thinking about other options like circles, then things will be very different. So let's just simply try to distribute objects over these circles. If I would like to distribute everything using this matrix, then I need the objects matrix output. This node is definitely interesting because the matrix, the idea of matrix is very vague in this case. If I put the object in and put the matrix in, you can see the object has been auto-oriented to the center of circles, which is very cool. But if you're working with a vector, objects transform output, then you need to use vector to redefine whether you want this vector goes through locations, rotation, or scales. Basically, that's kind of idea. But obviously, since we're trying to distribute objects over a 3D space, it's basically always right to put this vector into location, and object goes to object. Let's just update trees. So now you can see it distributed the objects, the cube, but it does not orient all these cubes. It just stays as it is. So maybe this is something you want, or maybe this is something you don't want. So by working with these two examples, you can see working with vector is something more intuitive at some level, because you just add a vector math. Then you can easily change all these things. But if you're working with matrix math, it does not seem very intuitive because you only have a multiply operator, and this I will elaborate later. But instead of having add, subtract, multiply, divide, cross, project, reflect, normalize, blah 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 blah, blah whatever, all these kind of things, matrix math is very vague, where it only has multiply. So it's not very intuitive at some level. So it might be an advantage to use vectors sometimes if you want to do more kind of simple intuitive stuff and you don't care about rotation or scales at some level. And in that case, how can I actually get the orientation in the right place? Then I need to use a node called the direction to rotation. So if I plug this vector to the direction, then I'm generating a Euler number. If you plug that to rotation, then you get the same result as you're doing with matrices. And another thing I want to remind you is matrices also contains scales, as mentioned earlier. And in spiral, you actually have scales. So in that case, now if we generate some more objects on these spirals, you can see objects will stay the same size because information has not been included within that, of course. But if you're using matrix, object to matrix output, and put the matrix into that, so now I can see there's a change in the scale because it's also something has been mentioned in the setting. So basically matrix contains more info, but it's very less intuitive about how to add and minus. The next thing I would like to mention is matrices does not only include more information compared to vectors, it's also more accurate than the vectors. So if I have an object, and if I parent this cube to empties, so now if I'm moving these empties, the cube also moves. And then if I'm lifting these empties, you can see the transform of these empties is very high, like 6 meters on the axis. But if we take a look with this cube, because it has been parented to these empties, so it seems like this cube is not moved relatively, and its location is 0, 0, 0. So in that case, if you try to read its location using objective transform input and take the 3D viewer or the viewer as well, so just read its location. Its location is still 0, 0, 0, and its 3D viewer location is in the world origin. So by using the parentings, you can see its transform inputs is completely dead. So sometimes maybe this is what you want, but other times if you're using these things to trigger a fall, if you would like to use the location of this cube to trigger the fall, then this using the vector or the transform will not work. And the other cases where the transform will not work is if you're activating the physics. So now let's just generate another cubes. And if I play this animation, then it will just fall. But you can see the location does not change at all. It's beyond the controls of the transform. It's not the transform that drags these cubes, but something else drag these cubes down. So if I would like to use the location of this cube to do something, then I cannot actually use this object transform input. And here's where I need an object matrix input. So although intuitively it does not really show you anything, but if you decompose that, then you'll get all the information: translation, rotation, scales. And now let's take the 3D view again. Then you can see the vector marker goes to the exact location of this object if you're talking about the matrices. So the matrix essentially is more accurate compared to vector or the transform data. And another thing I want to mention is it does not only talk about the words, it can also talk about the options like a word basis, local, and a parent inverse. Essentially, you can know more from the menus in that case. So that's it. I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.